Okay. Today we are starting. Today we are starting new chapter, lenses. What is a lens? We say a lens is a transparent medium bounded by two surfaces which are generally curved. Which are generally curved. So definition probably in ICC level will not come. We have two type of lenses in syllabus. One is convex and one is concave. In lenses, any kind of lenses, the image is formed due to refraction. But in mirror, the image is formed due to reflection. That is a basic difference. We have two lenses in syllabus. One is called convex lens and one is concave. The shape of convex and concave are like this. This is convex. This is concave. Convex is also known as converging. Converging. Concave is also known as diverging. Diverging lens. Shape you should know. This is the shape of convex lens. This is the shape of concave lens. Convex lens is thicker in the middle, thinner at the edges. Concave lens is thin in the middle or thinner in the middle and thicker at the edges. Thicker at the edges. Definition will not come. Main thing you only learn. In any lens, the geometric center of the lens is called optical center. The geometric center is called optical center of the lens. Optical center, denoted by O. What is the property related to O? Any ray, an incident ray through O, will not bend, it will go straight. An incident ray through optical center does not get deviated after passing through the lens. It will go undeviated, it will pass undeviated. That means any kind of incident ray through O will be going straight without bending. This ray will go straight. Here also the ray will go straight without bending. Any kind of ray. This ray also will go straight. This ray also will go straight. All the rays passing through O go undeviated. Okay, this is the property of optical center. But what is the reason why it goes undeviated? Do you know the reason? One of you can share with me. Why does a ray through? Do you think this ray is perpendicular? It is not perpendicular. Anybody can? It is parallel. Where it is parallel? The ray is not. Why does a ray through the optical center pass undeviated? Anybody? Tell me the reason. An incident ray through the optical center does not bend and it goes straight. Why? Pratham, anybody? Pratham is there? What focus? There is no focus on here. Optical center I am talking about. No, that is the reason. Question is only that only why it passes undeviated through the optical center. Yes, Oshik. Oshik. RI is same. Where is RI? This is air, this is glass. RI is not same. Who said that? No. RI, how come RI is same? This is air, this is glass. Okay, Pratham is there. Lens is thin over here, no, on top. Anybody else? Okay, now I'll tell you the reason, okay. Perhaps you do not know, so I'll just tell you the reason, okay. First, I'll draw a lens. Here is the optical center. I said a ray passing through O does not bend, it goes straight. Reason is this, okay. This part, if you look at this part is looking like, behaving like a prism. In a prism, no, if we are having a prism like this, a ray will go through the prism, it will go and it will bend like this. The ray, emergent ray always bends towards the base of the prism. The emergent ray always bends towards the base of the prism. If the prism is like this ray will go here, it will bend towards the base here, and it will come out further towards the base like this. The emergent ray will be always bending towards the base of the prism. If a ray comes like this, now what happens to this ray? This ray will bend towards the base of the prism. It will bend. It will not go straight. Okay, now if I take it this way like this part is behaving like a trapezium block, trapezium. If I take this is also like a trapezium. This way also it is a prism. This way also a trapezium block. But the central part of the lens like this. The central portion of the lens behaves as a rectangular glass block. This is looking like a rectangle. The central portion of a lens behaves as a very thin rectangular glass block. And if the rectangular glass block is very thin, the thickness is very less, so lateral displacement also is very small. That's why a ray of light passing through O will slightly bend and will come out, and it will appear like this, slightly bend and will come out as if it is not bending only. Lateral displacement is negligible, or lateral displacement is almost zero. If you're not understanding this one, so I'll just explain to you over here. Suppose we are having a rectangular glass block. Ray of light normally comes like this. It will go like this, and further it will bend. So this ray are parallel. So what is the normal displacement like this? I mean, lateral displacement is this much. This is the lateral displacement. But if the glass block is very thin like this, or thin glass block, you can have a look at it. If the glass block is thin over here, the ray will go like this, and lateral displacement will be small here, less lateral displacement. But if the glass block is really very thin, like this, very thin, what happens? The ray will bend slightly and again will come out like this. So these two rays look like as the same ray. So this ray, incident ray and the emergent ray are almost looking like the same. The lateral displacement value is almost zero. And the ray will appear to be not bending on passing through this glass block. It is going straight. It looks like that. So the same thing happens in the ray, the central part of the ray behaves as a rectangular glass block of very small thickness, which produces negligible lateral displacement. Please mute your sound. Please mute your sound because I'm getting disturbed. Please write down, make a note. Write it down. An incident ray, please write down this reason. An incident ray through the optical center, an incident ray through the optical center of a lens, an incident ray through the optical center of a lens passes undeviated because Yeah, because the central portion, because the central portion, because the central portion of a lens, because the central portion of a lens acts as a acts 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 as a very thin glass block, acts as a very thin glass block, very thin glass block, producing 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 negligible producing negligible lateral displacement, producing negligible lateral displacement, producing negligible lateral displacement. Hope you understood this point. All right, boys. So lateral displacement through the central part for any incident ray is zero, almost zero, or nearly zero. That's why the ray does not seem to be bending on passing through the optical center. Okay, that is the reason. Okay. Now, in a lens, suppose we are having a lens like this. This is the optical center. A straight line passing through the optical center is known as principal axis. This line is known as what? Principal axis. And the vertical line, horizontal line is principal axis, and this vertical line is called, which divides the lens laterally into the two parts. This line is called axis of the lens. This line is known as axis of the lens, and this is called principal axis. And this is optical center. Here is optical center. On the principal axis, this is the principal axis, we have two important points. One point we mark F, another point we mark also as F. This is F1, this one will mark F2. F1 and F2 are 2 points on the principal axis. They are called focus of the lens. This is called first focus or first focal point. This one is known as second focal point, F2, second focal point. This is also known as principal focus. Principal focus means main focus. Principal focus. F1 is also known as auxiliary focus. Principal focus and auxiliary focus. What is the definition of second focal point or the principal focus of a convex lens? We see the property. What are the properties of these two focus? Properties that is an incident ray, yes. An incident ray parallel to the principal axis. Any kind of incident ray which is parallel to the principal axis on passing through the convex lens will actually pass through this one. This ray will be passing through F2 point like this. This is the property of F2 of a convex lens. An incident ray parallel to the principal axis will be passing through F after reflection. Same way, if the ray comes like this, it will pass through F. If the ray comes like this, it will pass through F. Ray coming like this parallel, it will pass through F. All the rays parallel to the principal axis always pass through the F2 point of a convex lens. So if the definition we have to give, we give the definition like this. If it is the point on the principal axis of a convex lens through which an incident ray parallel to the principal axis after refraction from the lens passes. This diagram we keep in our mind. By chance, if the definition comes in exam, define second focal point or define the principal focus of a convex lens. We keep this diagram in our mind and we will be defining according to this diagram. Is it understood? Now, what is auxiliary focus? Okay, and what is the property related to auxiliary focus or first focal point? The property of auxiliary focus is that an incident ray through O, any kind of ray passing through the auxiliary focus, after refraction from the lens will become parallel, just opposite of this. This ray will now become parallel like this. This is the property of auxiliary focus. Auxiliary focus will put the ray parallel, and this ray, the principal focus will make the parallel ray passing through that point. So in a lens we have two focus or two foci, first focal point, second focal point, auxiliary focus and principal focus. How can we define auxiliary focus of a convex lens or first focal point of a convex lens? We say it is a point on the principal axis through which an incident ray after refraction from the lens becomes parallel to the principal axis. We'll keep this diagram in our mind and we will be able to define. I draw another ray lens. Suppose this is the ray going like this. What will happen to the ray? They will become parallel. All the rays passing through this point will go like this and become parallel. Any ray through O or through F1 after refraction from the lens becomes parallel. Understood? Now, the distance of the two focus from optical center, they are called focal lengths. Focal lengths. This distance is called focal length, also focal length. Or we say that O to F2, this distance is focal length. This distance is called focal length or length of the focus. Okay. The 2 points F1 and F2, 2 points F1 and F2 are situated at the same distance from optical center generally. This distance and this distance will be generally equal. Why? Question may come. Huh? Yeah, both the focal distance from the optical center are generally equal. Generally equal. Why they are generally equal? Because the medium is same. The answer is the medium is same. This side medium and this side medium is same. This is normally air. This side also air. Since the medium is generally the same on both the sides of the lens, this side and this side, the medium is same. That's where the distance F1 and F2 from O will be equal. When the distances, when the medium is not same, then the distances will not be equal. I'm giving examples. Suppose one side we have air, other side we got water. Then the distances will not be equal. In a denser medium, the focal length will be far away. This is air, this is water. That means the distance of F2 will be far. The distance of focal length in the denser medium will be far away from the optical center. That means two distances will not be equal. That means F2 distance will be more than the distance of F1. In case of a denser medium, I am talking about. You keep in mind. All right. But in this is air, this is water. If it is like that, one side is air, one side is water, then the distance F1 and F2 will not be equal. Because water is a denser medium, no? This distance will be far in a denser medium. And in the air medium, this F1 distance will be closer. But if the medium is same on both the sides, this side medium is the same, then the distances will be also same. Is that clear? Keep in mind, don't forget. All right. Please do respond. Now I talked about this one, a concave lens. Suppose we are having a concave lens like this. Here is the suppose optical center. The ray is like this. Here again mark 2 points here also. F, here also will mark F. This time F2 will be here, F1 will be here. This time principal focus will be here, principal focus. The main focus is this side, principal focus. And this is called auxiliary focus, auxiliary focus. Second focal point and first focal point. F2 means second focal point, and this side we have first focal point. Okay, what is the property of principal focus? The ray coming parallel to the principal axis here like this. Will not pass, will appear to pass through this point, dotted line here like this. An incident ray parallel to the principal axis after passing through the concave lens appears to pass through a point, and that point is called principal focus. It will not actually pass, but it will be appearing to pass by dotted line, imaginary line. That means this concave lens will diverge the ray, will spread the ray, and convex lens will converge, will be focusing the ray. So how, if question comes, define principal focus of a concave lens, principal focus or the second focal point. We'll keep this diagram in mind. How do we define? We say it is a point on the principal axis of a concave lens through which an incident ray parallel to the principal axis after refraction from the lens appear to pass. Appear to pass. We'll mention that the word appear to pass. And what is the property related to the auxiliary focus? Auxiliary focus will make the ray parallel. Just the previous one we did. So if a ray is coming like this, as if it is appearing to pass through this point, then the ray will become parallel. An incident ray which is appearing to pass through dotted line, which is appearing to pass through F1, after refraction from the lens will become parallel to the principal axis. That means auxiliary focus makes the ray parallel, and principal focus will be dealing with the parallel. The ray will already be parallel, and the principal focus will make the parallel ray either to actually pass through or appearing to pass through that point. Whereas the auxiliary focus will make the ray parallel. These two diagrams we keep in mind if by chance the definition comes in ITC. And I have already shared the definition, so please you can note it down from the video which you will be getting. From that video you can write in your copy the definitions which I have already said. You can slow down the speed, and in slow motion you can just note it down. Hope it is clear. Any doubts you can ask me to do again or to explain again, and also then otherwise if it is fine then yeah. Definition I already shared no in the video. You will get the video no, so from there you will write down definition. Or these two. Axis of the lens. Vertical line is called axis of the lens. Axis of the lens. All right. Okay. For any confusion or anything you want to write it down and all, so first understand, and then you can slow down the videos and write down nicely there. Pause, write down, pause and write down. The best equipment you all have the video with you, so you can make use of that. Okay. Now, next part we are doing is formation of image. This is the important part actually. Formation of image by a convex lens, by a convex lens. Formation of image by a convex lens. Here we have 6 cases. Different cases are there. I think you would be remembering class 8. The first case we will be having when the object is at infinity. You can write down when, first case is when object is at infinity. That means when the object is very far. First, we are showing the formation of image by convex lens. For that, we will be drawing a principal axis. Principal axis will draw. Okay, how to draw the principal axis? You draw a line overwriting the ruled line of your page. Overwriting. So you choose one of the ruled line, keep some space above and some space below. Choose one of the ruled line of your copy and overwrite. Draw it over the same line. And somewhere in the middle, we'll be drawing a vertical line. This is the axis of the lens. Height, say this height should be same. For the sake of convenience and perfectness, I'll take the height of this line equal to 3 lines. 1, 2, 3 rule lines. Exactly 3 lines up, 3 lines down. And mark this as L. L means lens. This is optical center. Now I'll mark 2 points. They are focus point. I know the 2 focus are same, should be at the same distance from optical center because the medium is same. So for the sake of accuracy, from here I'll take one focus here, 2 centimeter. With the ruler, 2 centimeter you measure, and this side also measure 2 centimeter. Mark here F2, and further 2 centimeter mark to F2. This side mark F1, further 2 centimeter from here, same distance to F1. This is F1 and this is 2F1, double of this. For the sake of accuracy, we are taking the distance from O to and further 2 centimeters. This is also 2 centimeters, further 2 centimeters. Using ruler, we have to do it, using ruler. Now we draw the object, or we see where is the object. When the object is at infinity, then object will be too big. We cannot draw it. Infinity object will be sending the rays parallel, like this in the form of parallel rays will come. So I'll show one ray above the principal axis, one ray above. Parallel ray above the principal axis. What will happen to this ray? This ray will pass through F2 because this is convex lens. Convex will convert the ray, will make the ray actually passing through F2. So it will be actually passing through F2 here. Mark the arrow here and arrow here. No arrow, no marks. Keep in mind. One ray will put it down, will draw it below. Exactly one line above, one line below. We'll do that. This ray will also pass through F2. We know the property of F2. All the parallel ray passes through F2. We take one more ray because infinity object, no, the image will be bright or can be seen only when many rays will be passing through and form the image. One more ray will take above it. This will also pass through F2. One more ray will take below. This will also pass through F2. All the rays are meeting at this point. Here is the image form. Final and finishing touch we will give by drawing the lens convex. This way. Try to make a thin convex lens, thin. Don't make it so bulging one, so thick one. Make the thin lens. This portion should be thin. So this is how we draw the diagram. And now write down characteristics. Characteristics of image. Characteristics of image. Number 1. First character we'll see. First we have to mention where is the image formed. Location we will say first. Position. You can see the image, all the rays after refraction is meeting here at this point. Where the rays meet after refraction, there only the image is formed. We say image is formed at F2. Right here, formed at F2. Or we can say formed at F. F is principal focus. F2 means principal focus. Number 2, we see the image is real because the rays are really meeting at that point. We say real. And real image will be always inverted. We write it inverted. And the 4th point we write size. What is the size of the image? Highly diminished, we write here. Highly small. highly diminished. Very small like a point, highly diminished. They write uses or use. Use of this ray diagram. Where do we make use of this ray diagram? Okay, right on. This action of convex lens is used. This action of convex lens is used in burning glass. In burning, burning, in burning glass. Burning glass. This action of convex lens is used in burning glass. burning, burning glass. Burning glass. GLASS. Burning glass. Okay, now I give example. Burning glass. This action of convex lens is used in burning glass. burning glass. Okay. This action of convex lens is used. This action of convex lens is used in burning glass. Okay, no. Okay. Spelling of what? Yeah, see the video. Okay. Now listen. Okay, now just one. I won't take my time. Now 1 minute more. Okay, just listen. If they ask draw a diagram to show that the convex lens is a converging lens, this is a diagram. All the rays are converging, focusing at that point. So this is a diagram you draw. I think you all must have seen this magnifying glass. Have you seen a magnifying glass? Which we permission of they use this kind of glass. They use this kind of glass like this. Magnifying glass. Magnifying glass is nothing but a convex lens. This lens is only there. When you place in front of sun, you see there will be a sharp image formed there. This is the image of the sun. Sun rays will be converting like this. Sun is too big inside, but the image is very small, like a point. And when you keep a piece of paper here, if you keep a piece of paper over here at that focus point, you will find that the piece of paper will start burning after some time. After keeping for half an hour or so, the piece of paper will burn. You know why it will burn? Because sun rays, this is the sun rays coming here and converging at that point. And sun rays contain heat also. Due to the too much heat focusing at that point, the piece of paper starts burning. So name the lens used as a burning glass. If question comes, you say convex lens. Draw a diagram to show its action at burning glass. Then you draw this diagram. So we do this much for the day. Yes. You can. Yeah, magnifying glass is nothing but convex lens only, no? Magnifying glass. No, example for what? This is the diagram you draw. Why to write? No, why to write magnifying glass? You have to write magnifying glass is nothing but a convex lens. You have to say convex lens, no? Okay. All right. Thank you, boys. Was it clear? Huh? Yeah, you can leave now. Thank you. Thank you very much. Okay.